Okay, you're given this piecewise function down here, and we want to make A and B have values that allow this function to be continuous. Here's the definition of continuity. At a given point where x equals a or t equals a, the function has to exist at that value of t. The limit from the left and right has to be the same so that this limit exists, and that limit has to equal this function value. So I'll let you look this over. For the technique for showing that, here's an example of the graph where we have values of a and b. Function is not continuous. We need somehow for these 2 points to overlap each other, and the same for these 2 points over here. We've got jump discontinuities there. If I click this Make Continuous button, there's what the function value, or there's what the function looks like when it's continuous. Okay, so how do we do that? First of all, let's make it continuous at t equals 0. Does h of 0 exist? Well, if t is equal to 0, we're using this rule right here because t is equal to 0. So if I put 0 in for t, 2 cosine of 0, cosine of 0 is 1. 2 times 1 is 2, minus 3 is negative 1. If we want to find the limit from the left and the right of 0 to make sure that the limit as t approaches 0 exists, well, we'll plug 0 into this piece right here to find the limit from the left of 0. And if we put 0 in for this t, we just get a b. And if we want to find the limit from the right, well, we'll do the same thing we did from for the function value. Put 0 in for that value of t, we get negative 1, and for the limit to exist, the limit from the left has to equal the limit from the right, which means b has to equal negative 1, and the function value is negative 1, so that's the value of b right there. To make the function continuous at t equals pi over 2, we want to first prove that the function exists at pi over 2, which means we'll still use this rule right here, or equal to pi over 2. 2 cosine of pi over 2, cosine of pi over 2 is 0. 2 times 0 is 0. 0 minus 3 is negative 3. Now the limit from the right of pi over 2 means we're using this rule. So if we put pi over 2 in here for t to evaluate the limit, we get a sine of pi over 2, and then we already found out that b is negative 1, so this is a minus 5. The sine of pi over 2 is 1. A minus 5 is the limit as t approaches pi over 2 from the right. These two values have to be equal. So a minus 5 has to equal negative 3, which means a is 2. And this table kind of shows what's happening. Here, the value of a has been set to 2, b has been set to negative 1, and we can see for this group right here, the function value at 0 is negative 1. If we come in from the left of 0, it looks like we're getting really close to negative 1. And if we come in from the right of 0, we're getting really close to negative 1. So the limit equals the function value. And for this group right here, we're looking what happens at pi over 2. The function value at pi over 2 is negative 3, which we've shown. And just to the left of pi over 2, 2.9998, negative 2.998, we're getting really close to negative 3, and similarly, just to the right of pi over 2, we can get as close to negative 3 as we want. Okay, there we go. There you go. Hope that helped. If you have any questions, post a comment.